So Stephen, are you getting me, please?
Yes, teacher. Thank you.
Yes, I believe in O level you have learned linear motion also.
Yes, teacher.
What are some of the things when we are talking about linear motion, you should not leave them out? What are those things? What are some of the things whenever we are talking about linear motion, you should never even skip your mind. When you talk, someone you hear linear motion, hey, we talk about this, we talk about this. What are those things? What are those quantities that we normally measure? Or that we normally talk about on a linear motion?
You have speed.
We have speed. What else? Speed
You have
or
velocity.
speed or velocity? Speed or what? Velocity. We shall look at why I'm putting it like that.
Velocity.
Then what?
Acceleration.
Acceleration. We have acceleration. What else?
Acceleration.
Yes, acceleration. I've already put it there. Is there?
Energy.
Energy. You are talking about energy. Which means for something to move, there must be energy exerted. No, so?
Yes.
But we shall not look at them. We shall not look at that one right now. That one will be a topic on its own. Energy will be a topic on its own. Work, energy, and power. Okay? Okay?
Yes.
We can also look at talk of what? Distance. Or what?
Displacement.
Distance or displacement. Good. We can also talk of. You can also talk of time. Not so. You cannot leave out time. Okay?
Yes.
So we are saying linear motion. Definition: linear motion. Linear motion. Linear motion is a type of motion. Is a type of motion. Is a type of motion. Is a type of motion in a straight what? In a straight what? In a straight line.
Straight line.
Yes, Nalubega?
Yes, teacher.
Yes, you came back late. Why?
Teacher, I came when you were then talking.
Hey, so but you are only quiet. Hey, it's okay, it's okay. It's okay, Nalubega. It's okay. You say linear motion is a type of motion in a straight what? A straight line. Now let's look at term use. Terms used in linear motion. Term used in linear motion. Term used in linear motion. The first one there we have, is distance. The first one we have there is distance. Please, distance, is there anything that you don't know what is distance? Huh? Who doesn't know what is distance? Distance is the length between two fixed points. Is the length between two fixed points. Is the length between two fixed points. So if I have these ones, this is point A, and I have point B, and I have point B. Okay? So the length AB is what we refer to as distance. So the length between two fixed points is what we call distance. And remember that length is measured in what? Length is measured in what? Meters. So you said its SI unit is meters. Its SI unit is what? Meters. Members, when you see any question which is asking for SI unit, you first write the units in words. After writing the unit in words, then you write the symbol in brackets. Then you write the symbol in what? In brackets. Okay? Are you together, members? Yes. Then after that, it has a unit is meters, full stop. Distance is a scalar quantity. Distance is a scalar what? Is a scalar quantities. That is, it has only the magnitude. It has only the magnitude, but no what? No direction. So when I say the distance between A and B is 20 meters. The distance doesn't matter. The distance doesn't what? Matter. So it means even if I'm to measure from A, I start my measurement from A to B, or I start my measurement from B to A, that distance still remains the same. Because distance is a scalar quantity, and a scalar has no direction, but it has magnitude. Are you together? The second one is, the second term that we should not also forget is displacement. We have is displacement. What is displacement now? Displacement is the distance. Is the distance moved. Is the distance moved or covered? Is the distance moved or covered in a specified direction. In a specified direction. Is the distance moved in a specified direction. Okay? Since the distance, its SI unit, these things are very important. Its SI unit is what? Is what? Baptist. What is the SI unit of displacement?
Meters.
Is it? Is meters. Meters. Full stop. Its SI unit is meters because it's still distance. Full stop. It is a physical quantity. Is a physical quantity. It is a physical quantity and belongs to so which quantity is that? It belongs to a vector what? Does it belong to? Displacement is a vector quantity, members. Displacement is a vector what? Is a vector quantity. And we know that vector quantities are physical quantity with both magnitude and direction. To give you perspective on that, to illustrate that, take for example, members, I know some of you are allergic to red. Please forgive me. I know some of you don't like red colors, but please forgive me for this lesson. Am I lying, Stephen? Stephen, am I lying? I know Stephen is allergic to red colors. Eh?
Yeah, I don't like it.
Okay. So let me put this one. This is point B. Then this is point C. So assuming the distance between AC, if AC is 5 meters, and also CB is also 5 meters. Are you together, members? Now, what we call displacement which means a body must be displaced. That's why you say that it must be in a specified direction, which means here we are interested in the direction. Now, take for example, you have moved from point A to point B. Are you together, members? If you have moved,
Yes.
if you have moved from point A to B, what will be the total distance? What will be the total distance covered? What will be the distance covered? Distance covered will be AB, not so? I mean, the distance covered will be AC plus CB, which is going to be 5 meters plus 5 meters, which will give us 10 what? 10 meters. That's the distance when you move from A to B. But when you say that a body is displaced, a body has been displaced. Now you have moved from A to B. Again, you have moved back. You have come back. I think that you have come back to point C. Now you have moved from point A to B, then from B to C. You see that the distance BC, now that one you are moving in a negative direction. So for the case of the distance, you are just going to say 5 meters. You're just going to say 5 meters. But displacement, what will be the displacement, members? Members, what will be the displacement? What will be the direction of displacement? Direction of displacement will be B2 what? BC, not so? Because the body has been displaced. The body was, you move from A to B, then from A, you have again, from B, you move again to point C. But along the same straight line, here we are looking at motion in a straight line, members. Take note of that. Motion in a straight line. That's why I've drawn a straight line. So which means the displacement will be BC. But now, when you just say BC, what is the direction? Remember we said is a vector quantity. Is a vector quantity, which means it must have magnitude and direction. So which means in this case, the distance will be negative 5 meters because you have moved from here up to here. The body has been displaced by 5 meters, which you can see then from there. So the negative there, the negative indicates the direction. Negative indicates the what? The right direction. And 5 is the magnitude. 5 is the magnitude. That's why we are saying that displacement is a vector quantity. Members, are we together on that? That is a displacement. Also, there's also another displacement in there, which we can get. A displacement can also be AC. Remember, the body was initially at point A. It moved from A to B. Now, again, from B, it has moved back to A. So, which means for you to get AB, we can say, I'm using now vector analysis. I'm using vector analysis, members. So, AB, the distance AB is the same as AC plus C what? CB. I want you to understand this concept very well. AB is the same as moving. To move from A to B, you first move from A, you stop at C, then from C, you continue to B. Now you find that AB, which is already AB, because I want to find the displacement. The displacement in this case is AC. The displacement is AC. So which means I can say minus CB. Minus CB equals to AC. Which means AC is equals to AB minus CB. But AC will be equals to AB, which is 10 meters, minus CB. CB, the distance is what? 5 meters. Is 5 meters. So you find that our AC is equals to what? 5 meters. This is positive displacement. This one is a positive displacement. Is a positive what? Displacement, because the body was here. But just because now you see you are moving from A to C, which means someone has moved from point A to point B, then back to point C. That's why it's a positive displacement. You can see the direction is positive. But this one we got negative because you have moved from A, again you are reversing back. Which means is a negative displacement. CB is a negative what? Displacement. Members, are we together on that? Members, am I together? Am I clear on that? Am I clear on that? You have understood the difference, the difference between distance and displacement. You have got the difference between distance and displacement, right?
So what is the answer from there?
You have got the difference, right?
Yes.
Okay. That is the displacement. Now the next one is it number 3 or number 4? Number 3. Number 3 is speed. We need to understand these terms very well. Otherwise, it is going to disturb us as we progress forward. Displacement, I mean speed, is the rate of change, of distance. Is the rate of change of distance. Full stop. Members, students always make these mistakes. When you talk of rate, rate is already referring to time, which means per. Rate is a means per. So it's the rate of change of distance, which means mathematically you can write it, you can say speed is equals to distance covered divided by time taken. Don't again say this speed is equals to the rate of change of distance with the time. Now you are repeating yourself. When you say again with the time, you are repeating yourself. Are you together, members? Members, are we together? Yes. So speed is equals to distance covered divided by time taken. Full stop. That one is clear. The SI unit. We've got the SI unit. The SI unit of speed is meters per second. Then you write in brackets the symbol meters per second, like that. You first write in words, then you write the symbol in the brackets. Full stop. Members, now when you look at this one, is speed a scalar or a vector? Is speed a vector or a scalar? Who can answer me that? Is speed a vector or a scalar?
Where do you get the two flows? Multiply with 22.
Vector.
Speed is not a vector. Speed is not a vector. Okay? Speed is a vector. Speed, it is a scalar quantity. Speed is a scalar quantity. Speed has no direction, members. Speed has no direction. So when I say that you are moving at a speed of 20 kilometers per hour, that one, there is no direction there. You have just given the magnitude, the speed at which we are moving. So that one is a scalar, it has only the magnitude. But now when you bring the direction in, when you said you are traveling, or I was teaching at a speed of, or at a rate of 20 kilometers per hour, due north, or due west, or due south. Now the south there is the direction. I will look at that one when we come to velocity. Okay, that one now we call it velocity. Members, are we together on that? Members, are we together? Yes. The fourth one, let's look at the fourth one. The fourth one is now velocity. The fourth one is velocity. So we said velocity is the rate of change. Is the rate of change. Is the rate of change of displacement. Is the rate of change of Displacement, full stop, is the rate of change of displacement. So we can say velocity is equals to change in displacement divide by time what? Divide by time taken. The SI unit of velocity, is meters per second. Is meters per second. Full stop. Is meters per second. It is a vector quantity. It is a vector quantity. Members, are we together?
Yes.
Good. Velocity is a vector, while speed is a what? Is a scalar. Take note of that, please. Take note of that. So let's call this one A. Let's call that one A. Then B, still under velocity. Uniform velocity. What do we mean, uniform velocity? We say uniform velocity is when the rate of change of displacement is constant. Is what? Constant. Uniform velocity is when the rate of change of displacement is what? Constant. Members, are we together?
Yes.
Good. Then we go to number 5. Let's go to number 5. Acceleration. We have acceleration. Acceleration is the rate of change of velocity. That is acceleration A is given by change in velocity divide by time taken. Now from that formula you can derive the units. From that formula you can also derive the unit from there. So after that you come and say the SI unit of acceleration. The SI unit of acceleration is meters per second squared. Which will give us meters per second squared, like that. So the SI unit of acceleration is meters per second squared. Full stop. It is a vector quantity. Why are we saying it's a vector quantity? Because it's the rate of change of velocity. And remember, velocity is already a vector quantity. Okay? So acceleration is a vector quantity. Let's call this one part A. Let's call that one part A. Then B, still under number 5, B, uniform acceleration. So uniform acceleration will be is when the rate of change is when the rate of change of velocity is what? Is what? Is constant. Is constant. Then C, let's look at C, deceleration. There's also what we call deceleration. 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 What is deceleration, members? What is deceleration? Deceleration is when, or is the, so just say is the negative rate of change. You can just say is the negative rate of change, is the negative rate of change, is the negative rate of change of what? Velocity. Is the negative rate of change of velocity. Is the negative rate of change of velocity. Members, are we together? Good. Good. Sub-heading, that one we have already looked at. Uniform acceleration, we have already defined it. There's no need of repeating it. So let's go to equation of motions. Subheading, equations of motions. Equation of motions. Equation of motions. There are 3 equations of motion, members. There are how many? There are 3 fundamental. There are 3 fundamental equations of motions. There are 3 fundamental equations of motions. Full stop. Let's look at the first equation. First equation of motion. First equation of motion. First equation of motion. First equation of motion. We are saying suppose we are deriving those formula now. We are deriving them. Suppose, you know, right? Are you able to see what is in the notes? On the side of the notes, are you able to see it? Members, are you able to see it? The side of the notes. Yes, so we are saying suppose a body moving in a straight line with a uniform acceleration, A increases its velocity from U to V in a time T. Then the definition of acceleration, now we shall use the definition of acceleration to derive that equation. So we shall say from acceleration A equals to change in velocity over time taken. Now, when we talk of the change in velocity here, members, change in velocities, when I talk of change in velocities here, I'm referring, there's what we call initial. We shall have initial what? Velocity, which we use letter U. Then there's the final velocity, which we use letter V. We use the letter V. So the initial velocity is the speed at which a body starts moving. Is the speed at which, or is the velocity at which a body starts what? Moving. Then the final velocity is a velocity with which the body ends the motion. We remember we said whenever a body starts, there must be the end point, there must be the starting point and the end point. So the speed at which it will end that motion is what we call the final velocity. Then the starting velocity is what we call the initial. Okay? Are you together, members? So with me now? Yes. from acceleration now, which is equals to, so let me say change in velocity, change in velocity is going to be equals to final velocity minus initial what? Velocity. Minus initial velocity. So which means we shall have V minus what? Minus U. That is the change. This is the change in, that's the change in what? In velocity. Now, when I take it back to our equation, A is equals to where we say is a change in velocity. Change in velocity now is the same as what? V minus U out of what? Out of T, out of the time taken. Out of the time taken. So when you make the velocity the subject, when you make velocity the subject, you find out we shall have, it implies now we shall have AT is equals to V minus U. V minus U. So V minus U is equals to AT. So when I take that on the other side, therefore, our final equation becomes U plus AT. And that's the first, what we call the first equation of motion. That's how we derive it. Are you together, members? Are we together on that? Baptist, are we together? Baptist, are we together? Okay, Baptist is not able to hear me. Yes, Nalobega?
Yes, I'm there.
Are we together on this, Baptist? Members, we have a few minutes remaining.
I'm there.
Okay. Let's go to the second equation of motion. The second equation of motion. Second equation of motion. We want just to see how do we derive it? How do we derive it? For this one, we are saying, suppose an object with a initial velocity u move with uniform acceleration for a time t and attains a final velocity v. The distance traveled by the object is given by the distance covered by that. Remember, when you remember your primary formula, we said, this is side work, members. I'm just writing. Remember, we said speed. When you are still in O level, in primary, they say speed is equals to distance over what? Over time. Those are the formulas used to write, which means it implies that distance is equals to speed times what? Times the time. Yes. So now the distance moved or attained. Distance, we shall use letter S. For this time, we shall use letter S. So now, which means distance covered. Distance, we shall have distance covered is equals to the average speed. The average speed time. So which means distance covered. Please don't put me, please check your microphone, please. Check your microphone, please. So the distance covered now, which is S, is going to be equals to the average speed, average speed, which means you are adding two velocities and then you divide it by 2. So which means it's going to be final velocity plus initial velocity divided by 2. Then multiply it by time taken t. Multiply it by time taken, average. So final velocity plus initial velocity divided by 2 times the time taken. But members, if you remember very well, but from equation 1, from first equation of motion, from first equation motion, where we said V is equals to U plus A what? V is equals to. Now, where there's a V, I will substitute it with this. So which means my formula now will become S is equals to, I will have, instead of writing V, now we write U plus AT plus this U plus that one divided by 2, still time the time t. board mass, simplify bracket first, simplify bracket first. So which means you will have u plus u, which will give us 2u plus at over 2 times the time t. Now, distribute this one. When you distribute, this is the LCM. So when you distribute that, we shall have into 2u over 2 plus at over 2 times the t. Members, have I changed anything there? I've just distributed the LCM, right? I've just distributed the what? The LCMs. So which means I will have S is equals to, now what I will do? Now here we shall have U plus AT over 2, because these 2 will go away with the other 2. So from there, we shall have S equals to U plus AT over 2 times AT. Now expand that, expand that. So when you expand that, we shall have S equals to UT plus AT squared, because T times T over 2. So in a simple terms, now we just write it. Therefore, our S is equals to UT plus a half AT squared. Members, have you seen that? Members, have you seen that?
Yes.
Yes.
Yes. Yes, teacher.
Very good. Very good. You should know how to derive these formulas. That's why I'm deriving for you, please. They may tell you to derive these formulas. Okay? Members, are you getting me? You must be in position. You must
Yes.
know how to derive these formulas.
Yes.
Yes.
I can do them.
Yes. Also, or what's alternatively, someone may use a graph. When you draw a distant time graph, from distant time what? From distant time graph, you can also derive this formula from there. Sorry? So this is it. I mean, should be from speed time graph, sorry. Should be from speed time graph. So this is our speed, this is our speed, then this is the time which must be in seconds, then speed which must be in meters per second. Speed or velocity, So I'm assuming you have started from initial velocity, then you have moved up to final velocity. You are accelerating. You have accelerated from that point, okay, up to
Yes.
up to the final velocity v. So we can get the gradient. We get what? You form a slope there. Then this is the slope or the gradient. Slope or what? Gradient. So
Gradient.
from here to here, you move for time what? That time taken is what? For t time, not so?
Yes.
Yes. So which means our slope. Remember, we say the rate of change of velocity is what? That is acceleration, not so? So our slope will be equals to change in what? In velocity divided by what? Remember, here is 0. Divided by change in what? Change in time. So our slope is our slope will be equals to the change in velocity. Remember now the final velocity will be what? V minus what? Minus u, not so? Members? Members, are you following me?
Yes.
We started late, so once it goes off, let's join back. Once you see it goes off back, let's join back, okay? So that we continue, okay? Are you together? Yes. So divide
Yes.
by, the change in time will be t, this one, this t minus 0, minus this 0. So you find that our slope will be equals to v minus u out of t. Out of t. V is equals to that. So, but the change, when you look at this one, the slope is what? The slope is acceleration. We say the slope of velocity